This is, hello, this is homework help for section 5.7. And we are going to start with number 53. Okay, this one is a little bit tricky because you are going to use your u substitution and you are going to use that for the square root of t. Now, when you do the u substitution for the square root of t, we're only going to substitute it up here. Okay, and so let's talk about why. So I have u equals the square root of t. So that can be rewritten as t to the 1/2. So that is du dt is going to be 1/2 times t to the -1/2. Okay, if you want to rewrite that, that's du dt equals 1/2 on the square root of t. Okay, now I'm going to solve for dt. Okay, and when I do that, I end up with du times 2 on the square root of t equals dt. Okay, so now what I'm going to do is I am going to rewrite this, and I am going to put my u in here, but I am not going to put it in here. So I am going to have the cosine of u over the square root of dt. Then I am going to substitute for dt, which is going to be du times 2 on the square root of t. Okay, then our square root of t's cancel, and we are left with 2 cosine of u du. And that makes an integral that is, or an integration that is, we can do pretty quickly. So we've got 2, oops, actually we need to drop that sign. So I'm going to have 2 times the antiderivative of cosine of u, which is going to be sine of u. Okay, and then we've got to have our plus c. And now we're going to have 2 sine of the square root of t plus c. Okay, and the tricky part about this one is where we're substituting u here, but we're leaving this. And the reason that we want to leave that is so that we can cancel that out right there. Okay, so that was number 53. Number 61 is very similar. So let's look at number 61. We are going to let our u be x, and I'm going to go ahead and write x to the 1/2 right there. So du dx is going to be 1/2 x to the -1/2, and I'm going to rewrite that du dx as 1/2 on the square root of x. Okay, so then when I solve for dx, I get du times 2 on the square root of x equals dx. Okay, and so again, I'm going to substitute here, but I'm going to leave this one. So I've got secant squared of u over the square root of x times du times 2 on the square root of x. My square roots of x cancel. So I'm going to rewrite this as 2 secant squared u du. Okay, now you'll remember with your trig derivatives and integrals that if we take the antiderivative of secant squared of u, we are going to get tangent of u. So I've got 2 tangent of u plus c, and then I am going to substitute that back in. So I've got 2 tangent of square root of x plus c. And that is our answer right there. Okay. And then we have number 65, which is a beautiful algebraic trig problem that has quite a few steps. So we're going to do probably a half a page of rewrites before we even get to taking the antiderivative. So lots and lots of stuff going on here. So the first thing that I'm going to do with this one is I am going to rewrite using sine and cosine. Okay, so I'm going to rewrite using sine and cosine. You know, and sometimes these are just trial and error. It's just trial and error. That's why we need so much practice. So I've got the integration. Secant of theta is 1 over cosine of theta. Okay, tangent of theta is sine of theta over cosine of theta. Okay, and then secant of theta is 1 over cosine of theta. And then we have minus 1. Okay, so now the next thing that I'm going to do is I'm going to go ahead and write this as a common denominator. Okay, so I'm going to have, and again, I'm not doing any calculus yet. I'm doing actually mostly algebra. Now we do have to know the trig functions to do it, but what I'm doing right now is just algebra. So I've got cosine of theta, 1 over cosine of theta times sine of theta, cosine of theta. Okay. This is going to become 1 minus cosine of theta over cosine of theta right here. Okay. So just a quick little note right here. This is 1 over cosine of theta minus 1. So that's 1 over cosine of theta minus cosine of theta over cosine of theta. And that's how we get 1 minus cosine of theta over cosine of theta. So that's just some adding and subtracting a fraction that we're going to go over. Now what I'm going to do is I'm going to multiply. I'm going to distribute everything. Okay, so I've got sine of theta times 1. So that, and I still haven't done anything. So I am distributing this to this. And let's just go ahead and do one more rewrite before we do that. I am going to rewrite this right here. Before I distribute, I'm doing another rewrite. So this is sine of theta over cosine squared of theta. Okay, that's what that is right there. Okay, and now I am multiplying this times 1 over cosine of theta minus cosine of theta over cosine of theta. Okay, so that just gives you a little bit easier visual on what we're doing right here. So I'm going to go ahead and multiply this. So I'm going to have sine of theta over cosine cubed of theta. Okay, then I'm going to have sine of theta times cosine of theta over cosine cubed of theta. Okay, and again, I haven't done anything yet as far as calculus is concerned. All I've done here is just some rewrites. Okay, now I'm going to go ahead and make that two distinctive rationals. Okay, so I have sine of theta over cosine cubed of theta minus sine of theta over cosine squared of theta. And then all of this is d theta. Now, if you remember about our integration rules, I can take the antiderivative of this and subtract the antiderivative of this. Okay, and that's what I'm going to do. Okay, so I'm going to have the integration of sine of theta over cosine cubed of theta minus the integration, and whoops, I need to put my d theta. Okay, minus the sine of theta, the integration of the sine of theta over cosine squared of theta d theta. Okay, now we're going to start doing our integration and finding the antiderivative. Okay, so I'm gonna do a new page. Let's do that. Let's do a rewrite. So we are right here. Sine of theta over cosine cubed of theta, d theta, minus sine of theta over cosine squared of theta, d theta. Okay, so what I'm focusing on now is just this part right here. Okay, I'm just focusing on this. So for just this part, I am going to have u be cosine of theta. Okay, now the derivative of cosine of theta, okay, so du d theta is negative sine of theta. Okay, now the antiderivative of cosine of theta is just sine, but we've got to take the derivative here. So be careful there, because if you lose your negatives, that's part of something, one of the things that we got to work on. So this is going to be du over negative sine of theta equals d theta. Okay, so over here, just for this first part right here, I'm going to have the integration of sine of theta over u to the third, okay, times du over negative sine of theta. Now be careful, because it's very easy to lose that negative 1. It's very easy to lose that negative 1. And so we've got the integration of negative 1 over u to the third du. Okay, so I was just focusing on this part right here, and I still haven't taken the antiderivative yet. Okay, now let's do the same thing over here. U is still going to be cosine of theta, okay, but just here I've got sine of theta over u squared. Over here I had u to the third, but now I've got u squared. And so then I'm going to substitute for d theta. And so that's going to be du over negative sine of theta. Okay, and again, don't lose that negative 1. Okay, that's where students make mistakes with this one, is they lose that negative 1. Okay, and so this is looking a little bit more manageable. And before we take the antiderivatives of these, I'm going to do one more rewrite. And I am going to write this as a negative exponent. So I have the integration of negative 1 u to the negative third du minus the integration of negative 1 u to the negative 2 du. Okay, so now we are at the point where we can do some calculus. Okay. So I've got negative 1 u to the negative 2 over negative 2 minus negative 1 u to the negative 1 over negative 1. So we got a whole bunch of negatives that we got to look at. Okay, so now let's do a rewrite here. I've got a negative and a negative, so that's going to be a positive. And this u to the negative 2, we're going to move that to the denominator. So I'm going to have 1 over 2 u squared. Okay, and then I've got a negative here and a negative here, so that's going to make that positive. We're going to keep that negative sign, and then I'm going to rewrite that u to the negative 1 in the denominator. So then I have minus 1 over u. Okay, and then of course we have our plus c. And then we know that u is the cosine of theta. So I have 1 over 2 cosine squared of theta minus 1 over cosine of theta plus c. That is a fun problem. So, okay,